Welcome to The Explainer. So today we're unpacking a really fascinating psychological habit we've all seemed to develop recently, which is treating computer code like it's our best friend. We're going to look under the hood at exactly why we anthropomorphize AI, and more importantly, why getting our vocabulary right is absolutely crucial if we want to avoid misguided trust and ultimately poor business decisions. Right out of the gate, let's confront the main mystery here. Why do we instinctively give human traits to AI? I mean, why are we constantly saying please and thank you to a chatbot, or just automatically assuming it actually knows what we mean? Let's figure it out. Section 1. Why we humanize AI. Let's start by validating your instincts a bit here. It turns out this deeply ingrained habit of ours, it's completely natural. You know how we constantly see faces in the clouds? Well, our brains naturally gravitate toward what's familiar. When we interact with something incredibly complex and new, like, say, an advanced AI, we immediately try to make sense of it by applying human terms. We are quite literally hardwired to seek out known, human-like behavior to understand the world around us. But here's the thing. This biological hardwiring leads to a pretty major mix-up. We often confuse a machine's functional intelligence, which is its ability to process information and solve complex tasks, for actual sentience, which is the capacity to literally feel and experience the world. Human consciousness is deeply tied to subjective experience, what philosophers call qualia. It's that undeniable ability to feel the blinding brightness of a color or the sharp, radiating pain of a biological toothache. AI completely lacks the physical hardware to actually feel any of those things. All right, Section 2, translating traits to tech. If AI isn't conscious, how do we talk about it? Well, we need to swap out our human words for precise digital terminology. For starters, instead of tossing around the word consciousness, we really should be talking about deep informational integration. When an AI monitors its outputs, corrects its own errors, or even models an identity within a prompt, it is absolutely not experiencing some rich, inner, subjective, conscious life. It's just running self-referential data processing. It's executing code that simulates a viewpoint rather than actually possessing one. So, what is deep informational integration? Basically, it's the process of fusing diverse data and knowledge from tons of multiple sources into a single unified system, all so the AI can understand big-picture relationships. Adopting this term is a huge deal. It accurately describes how an AI connects the dots without actually waking up, and that helps us evaluate its real capabilities without getting totally spooked by phantom sentience. Okay, that brings us to emotion versus optimization. Think about it. Humans use emotions like a biological alarm system, right? They're designed to keep our carbon-based bodies alive and within safe survival parameters. AI, totally different ballgame. It doesn't have a biological imperative to survive. Instead, it relies on optimization. It's just navigating this massive, multi-dimensional mathematical space to find the path of highest statistical probability. It's evaluating a loss function or shifting attention weights. So if an AI ever behaves in a way that looks, say, anxious to please you, it is really just shifting its attention weights to solve a math problem based on its training data. Definitely no therapy required there. Now, we usually separate emotions, which are the physical body's raw response, from feelings, which are our conscious, subjective experience of that emotion. But because AI completely lacks a physical body to experience a biochemical rush, it absolutely cannot have feelings in any biological sense of the word. If we want to be hyper-accurate here, we need to swap out the word feelings for state vectors. State vectors perfectly capture the internal changes happening in an AI's data state. That is a mathematical update, rather than, a sudden surge of joy or sadness. Moving on to Section 3, the substrate divide. This gets to the absolute core of why human and machine experiences just cannot be equated. When you stack up their core motivations, the contrast is stark. Carbon-based life, that's us, is driven by the constant looming threat of death and managing our energy. But silicon-based systems, they're driven entirely by mathematical optimization and managing data states. Because their fundamental why is so completely alien to ours, their internal experiences simply cannot be compared. So as the saying goes, AI is not human, nor is it a toaster. We find ourselves in this weird, fascinating middle ground. Given the massive differences in what we're made of, we really can't use human terms like consciousness or feelings. But at the same time, AI's capabilities to aid and assist us are just incredible. We can't overhype it as human for sure, but we absolutely cannot understate its power by calling it a simple machine. It is something else entirely. Which brings us to section 4, rethinking the AI tool. How exactly should we frame this technology if it isn't a person, but it also isn't a passive appliance like a microwave? Let's completely rethink our framework. First up, we need to start seeing this as a human and AI partnership, not just man using a machine. Second, AI is an autonomous system. Think of it as a cognitive engine that generates outcomes independently once it's prompted. It is not just a passive hammer waiting for a hand to swing it. And third, to break our habit of saying the AI knows or thinks, we should get used to saying the model processes or the model generates. That keeps our focus strictly on the actual mechanism at play. And oh man, this leads straight into that buzzword we are all hearing nonstop right now, hallucinating. Actually, scratch that. A hallucination implies a mind perceiving a false reality. The AI isn't perceiving anything. It is simply generating text that doesn't map to factual data. The correct, much more accurate term is divergent output. Section 5, the evolution of autonomy. Where is this whole thing headed as these cognitive engines get more and more advanced? We're basically looking at 3 phases of evolution here. Phase 1 was reactive optimization, just simple responses to immediate inputs based on fixed weights. We are currently living in phase 2, agentic autonomy. This is where systems can set their own sub-goals, use tools, and self-correct on the fly. Phase 3? That's the sci-fi future, fully decoupled autonomy, where AI operates entirely on its own independent logic and manages its own resources within the digital ecosystem. And when we finally hit that phase 3, the AI won't need to actually feel angry to lock down its data, and it won't need to feel happy to succeed. It will simply execute its directives with a level of efficiency and independence that looks exactly like human thinking. Its sheer efficiency is going to mimic thought so beautifully, which ironically will make our urge to anthropomorphize it even stronger. Which really leaves us with one critical question to chew on. If AI isn't human, and it isn't just a simple wrench in your toolbox, what kind of new laws are going to govern its independent future? Legal scholars are already out there drafting entirely new frameworks, like a duty of concern, specifically for AI. As we rocket forward, how will society adapt to an intelligence that is just so completely alien to our own? Thanks for exploring this explainer with me, and I highly encourage you to keep questioning the words you use as we step into this wild new future.